Well, if you look at the reaction with 2,4-dinitrophenylhydrazine, that is 2,4-dinitrophenylhydrazine, this is abbreviated as 2,4-DNP, or we can say Brady's reagent. Brady's reagent. Suppose I have acetaldehyde. When this acetaldehyde reacts with 2,4-dinitro, that means in position 2, this is 1, 2, 3, 4, 5, 6, these are the positions. So if the nitro groups are attached in the second position as well as in the fourth position, so 2,4-dinitro, 2,4-dinitro, this is phenyl, 2,4-dinitrophenyl, and this is hydrogen. So 2,4-dinitrophenylhydrogen when the acetaldehyde reacts with. So what happens here? Water is removed, and it gives C double bond NNH, NO2. That means here 2,4-dinitrophenyl acetaldehyde 2,4-dinitrophenylhydrazone is obtained. Acetaldehyde 2,4-dinitrophenylhydrazone. Similarly, if you will take acetone, and reacts with (2,4-dinitrophenylhydrazine), this water is removed, and finally it gives this is acetone 2,4-dinitrophenylhydrazone. Hydrazone is obtained. So in this way, when there is a reaction with 2,4-dinitrophenylhydrazine, both the acetaldehyde, if it reacts with acetaldehyde 2,4-dinitrophenylhydrazine is obtained. If it reacts with acetone, then we get acetone 2,4-dinitrophenylhydrazone. So this is all about the reaction with 2,4-dinitrophenylhydrazine, which is the Brady's reagent. Now we look at the reaction with semicarbazide. So if we look at the reaction with semicarbazide, you see semicarbazide formula is NH2NHCONH2. Here it is nothing but we have hydrogen. In this hydrogen, one of the hydrogen is replaced by CONH2, that is amide group. That's why it is semicarbazide. Well, suppose I have formaldehyde. When this formaldehyde reacts with semicarbazide, H2N, NH, CONH2, what does it give? Water is removed from here, and it gives formaldehyde. Well, the reaction is H double bond NN, HCONH2, and the name of this product is, since we have taken formaldehyde, so formaldehyde semicarbazone. Formaldehyde semicarbazone. Formaldehyde. If we will take acetaldehyde, and reacts with H2N NHCO NH2 semicarbazide. Well, the water is removed from here and it gives acetaldehyde semicarbazone. Double bond, look at here, CH3 C bond H double bond NNHCO NH2. NNHCO NH2 followed with the water molecule. So this is, since we have taken acetaldehyde, that's why the product is acetaldehyde semicarbazone. If we will take acetone, and reacts with semicarbazide, then water is removed NNHCO NH2. Acetone semicarbazone. With the elimination of a water molecule. So in this way, when acetone reacts with semicarbazide, when acetone reacts with semicarbazide, it gives acetone semicarbazone. Similarly, so it's very easy to understand that reaction with semicarbazide, this is all the reactions followed by the elimination of the water molecule. Formaldehyde reacts with semicarbazide to form the formaldehyde semicarbazone. Similarly, acetaldehyde reacts with semicarbazide to form acetaldehyde semicarbazone. Similarly, acetone reacts with semicarbazide to form the acetone semicarbazone. So these are the three different examples which is the reaction with semicarbazide. This is all about the reaction with semicarbazide. Now we will look at the next reaction of the next chemical property of the aldehydes as well as the ketones. Well, if you look at the addition of ammonia, that is the 6 molecules of the formaldehyde reacts with the 4 molecules of the ammonia to give the 6 molecules of the water along with the CH2 6N4. The name of this compound, the name of this product is hexamethylene tetraamine. Hexamethylene tetraamine, or we can say urotropin. So the structure that I have done for you, when the 6 molecules of the water, when the 6 molecules of formaldehyde reacts with the 4 molecules of ammonia, then water is eliminated, water is removed, no doubt, but the compound which is obtained is urotropin. So the question there may be sometimes in the examination that how the urotropin is formed, or how the hexamethylene tetraamine is obtained, or what is the formula for urotropin, this is what, and how to draw this structure. You just remember, first of all, draw nitrogen, and at the 3 corner of the nitrogen, that means using trigonal planar, according to the structure of the trigonal planar, you put CH2, 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 and at the top write 1 nitrogen, and here 1 nitrogen, and again 1 nitrogen. So 4 nitrogen, 1, 2, 3, 4. 4 nitrogens are clear. Now what you will do, you will extend this and you will write CH2. Again you will extend this and you will write CH2. And the same thing, you will write CH2 here and you will attach here. That means see how many CH2 is there? 1, 2, 3, 4, 5, 6. So CH2 whole 6 and total N4. So this is hexamethylene tetraamine, or we can say urotropin. In this way that you need to do the structure, which is very much relevant for the examination point of view. This is all about the addition of ammonia. Now we'll move on to the next reaction, that is action with phosphorus pentachloride. So if we look at the action with PCl5, so what is this PCl5? What is the name of this PCl5? Phosphorus pentachloride. So this is phosphorus pentachloride. When the formaldehyde reacts with phosphorus pentachloride, the PO and here Cl3, that is eliminated, that is moved, and we have CH2Cl2. This is dichloromethane is obtained. Similarly, if acetaldehyde reacts with PCl5, then the same POCl3 is eliminated, removed, and we have 1,1-dichloroethane that is obtained. But when acetone reacts with PCl5, then 2,2-dichloropropane. 2,2-dichloropropane is obtained. So if the PCl5 reacts with formaldehyde, dichloromethane is obtained. If PCl5 reacts with acetaldehyde, 1,1-dichloroethane is obtained. If PCl5 reacts with acetone, then 2,2-dichloropropane with the removing of the same, that is POCl3. POCl3 is obtained. So this is with action with PCl5. That means if in examination point, if the acetaldehyde reacts with PCl5, what happens? If acetone reacts with PCl5, what happens? If formaldehyde reacts with PCl5, what happens? In this way, the various types of questions may come in the examination point of view, remember. And next we will discuss the action with Fehling solution. Well, if you look at the Fehling solution, action with Fehling solution, when aldehydes react with Fehling solution, a red-brown precipitate of the cuprous oxide is obtained, that is Cu2O. A red-brown precipitate of the cuprous oxide is obtained, no doubt. But first of all, that we need to understand that what do you mean by this Fehling solution? The Fehling solution is basically a mixture of Fehling solution A and Fehling solution B. So what is this Fehling solution A? Fehling solution A is an aqueous solution of the copper sulfate. Similarly, what is Fehling solution B? Fehling solution B, alkaline solution of sodium potassium tartarate. Alkaline solution of sodium potassium tartarate. So I think it's very easy to understand for you. So what is Fehling solution means? Fehling solution is a mixture of Fehling solution A and Fehling solution B. So what is this Fehling solution A? Fehling solution A is an aqueous solution of copper sulfate. Similarly, the Fehling solution B is alkaline solution of sodium potassium tartarate, or we can say Rochelle salt. So if we will mix the Fehling solution A and Fehling solution B, then what is obtained? CuSO4 plus NaOH. This is an alkaline solution of sodium potassium tartarate, or we can say the Rochelle salt. So when the copper sulfate, that means when the Fehling solution A mixed with Fehling solution B, then what the product is obtained? That is the Fehling solution. That means when CuSO4 reacts with NaOH, then what happens? It gives, if you will dissociate CuSO4, you will get Cu2 plus and SO4 2 minus, and if you will dissociate NaOH, you will get Na plus and OH minus. The positively charged part of this one will react with the negatively charged particle of this one. That means in this way, CuOH whole 2. This is copper hydroxide. It's a base. So copper hydroxide is obtained. copper hydroxide is obtained. Yeah. And this is the Fehling solution. That means, what is Fehling solution means? What do you say? Fehling solution is a mixture of Fehling solution A and Fehling solution B. So Fehling solution A is nothing but the aqueous solution of copper sulfate solution. Similarly, Fehling solution B is alkaline solution of the sodium potassium tetrate. And when Fehling solution A and Fehling solution B are mixed together, then what the product, that is copper hydroxide, which is a base, is actually the Fehling solution. So when aldehyde reacts with Fehling solution, what happens? Let's have a look. Suppose you see, I have aldehyde, RCHO. When aldehyde reacts with Fehling solution along with NaOH, yes, it gives RCOONA, sodium salt of acid, plus Cu2O. This is very much important. A red brown precipitate of the Cu2O along with the water molecule is also obtained here. But the most important point that we need to remember, a red brown precipitate, of cuprous oxide, a red brown precipitate of the cuprous oxide is obtained. Well, you remember, some of you might be thinking that what's the difference between this cuprous oxide and cupric oxide? Remember, generally the copper has variable valency. That means it has more than one valency. Sometimes we write the Cu plus, sometimes we write Cu2 plus. That means since the copper has two different types of valency, so this is what called the variable valency. When the copper, suppose let us take the first one, Cu plus, when it reacts with oxygen, that is O2 minus, then here the charge of this oxygen will come down here, that is Cu2O is obtained. If you will take Cu2 plus and reacts with oxygen, that is O2 minus, then you will get CuO. So remember, when a substance having the variable valency, which is the least valency, the substance having the least valency ends with OUS, and the substance having the higher valency ends with IC. That's why this is, since the Cu plus, here the Cu plus, it reacts with O2 minus, that is Cu2O, that is, this is called cuprose, OUS is obtained. So cuprose, Cu plus means cuprose, that is cuprose oxide. Similarly, this is Cu2 plus, reacts with O2 minus, that's why this is cupric oxide. So cupric oxide means CuO and cuprous oxide means Cu2O. So this is to make you very clear regarding to this the name of the Cu2O, I just said you this. But if you look at the Fehling solution, aldehyde reacts with copper hydroxide with the Fehling solution as well as the sodium hydroxide. It gives the sodium salt of acid, and the most importantly, a red brown precipitate is obtained. And this is what the Fehling solution, reaction or action with Fehling solution. This is one of the most important examination, I think, which is very relevant for the examination point, and it's going to come in the examination. And that's why I hope that if you would remember, then that you would get the best score. Well, this is all about the Fehling solution. Now we'll move on to, the reaction with, there are many other reactions as well, now we'll go to aldol condensation. So before the aldol condensation, let me tell you some reactions, that is action with Tollence reagent. This is also one of the most important questions. Tollence reagent means what basically? If somebody asks you that what do you mean by Tollence reagent, ammonical solution of silver nitrate solution. That is ammonical solution of silver nitrate. Ammonical solution of silver nitrate. that is called Tollence reagent. So this is Tollence reagent. And aldehyde. So when aldehyde reacts with Tollence reagent, then ammonium salt of carboxylic acid is obtained. So 3 molecules of ammonia, water, the most importantly a silver mirror is obtained. So that's the most important to remember. If you will take the specific example, put R, CH3 in the place of R, that you will get acetal, this is acetaldehyde. If it reacts with ammonical solution of silver nitrate, then it gives ammonium acetate. Ammonium acetate with 3 molecules of ammonia along with water, and we have a silver mirror is obtained. Well, if acetate, this is the specific example. So if in the specific example, if you look at, when acetaldehyde reacts with the Tollence reagent, then ammonium acetate, CH3COO, CH3COO NH4, the ammonium acetate ammonium acetate is obtained along with the 3 molecules of ammonia, water, and a silver mirror is also obtained. So this is what that we need to remember from the action with Tollence reagent. The most important thing is that you need to remember Ag, that is because this is what here it is obtained. Next we will discuss some of the reductions of aldehydes and ketones. Well, if you look at the reduction, aldehydes and ketones undergo a variety of the reduction, and it gives a variety of compounds. So the first one, reduction to alcohols. Let us take it as a catalytic reduction. Suppose I have aldehyde RCHO. When this aldehyde is reduced in the presence of nickel catalyst, then alcohol is obtained. Aldehyde. If you will take the specific example, if you will take the formaldehyde and reacts with hydrogen, that means reduction means what? Addition of hydrogen or removal of oxygen in the presence of this nickel catalyst, then CH3OH, that is methyl alcohol, is obtained. And here it is formaldehyde. If you will take acetaldehyde, what do you get? CH3 CH2OH, that means the primary alcohol, that is ethyl alcohol. Ethyl alcohol is obtained. If this is acetaldehyde, if you will take acetone, in the presence of nickel catalyst, it gives, you know, CH3, CH2, CH2, OH, that is propyl alcohol. Propyl alcohol is obtained. Otherwise you say, since the two alkyl groups are there, first of all here the primary, then here it gives secondary, that means RRCHOH. So RR means here CH3, CH3, CHOH. So this is the secondary alcohol is obtained when the acetone, it reduces with nickel catalysts. So there are various types of reductions. That is reduction to alcohols, that is the first one. You know, in the exact way, if you will place this lithium aluminum hydride here, in this case, that is LiAlH4, that means if the reduction takes place with complex metal hydride, that is lithium aluminum hydride, here also lithium aluminum hydride, the same substances are obtained. So the first reduction that we did with nickel catalyst, the reduction also, the reduction on the reduction with lithium aluminum hydride also, these compounds will give the same products, that is alcohol only, that is methyl alcohol, ethyl alcohol, or we can say, you know, the secondary or the propyl alcohol. This is what all it is obtained with the reduction to alcohol with, you know, catalytic reduction, as well as the reduction with lithium aluminum hydride, that means the reduction with complex metal hydrides. And the reduction also can take place with the sodium or alcohol. These are used as the different agents for the reduction of the aldehydes as well as the ketones. So the most important thing, Mervin-Pondorf reduction is also one of the most important reaction. Mervin-Pondorf reduction. I hope you to read the Mervin-Pondorf reduction as well, which may come in the examination point of view. So aldehydes and ketones undergo reduction, no doubt, but when it undergoes reduction, it forms the various substances. So just like it for how it forms the alcohol, the reduction to alcohol means how the alcohol forms. This is a catalytic reduction. The alcohols can also be formed by, you know, the reaction with complex metal hydride, that is lithium aluminum hydride. You know, the many other substances are also, that means there may be a chance of getting the formation of alcohol. Also, if you will take the sodium or alcohol as the reagent, that is also one of the reduction. And if you will reduce with Mervin-Pondorf reduction, then also the various other products are obtained. And here in the reduction, the most important, very important, that we need to know for the examination, for the relevant point, is that is Clemmensen reduction. Clemmensen reduction and Wolff-Kissner reduction. So we must know that Clemmensen reduction as well as the Wolff-Kissner reduction. Then after we will discuss the aldol condensation. Then after we will discuss the Kenny-Jaros reaction and difference between aldol condensation and Kenny-Jaros reaction, so that the chemical property of the aldehydes and ketones will be closed. Well, that's what we are all going to. This is what we are going to discuss in the next video lecture. This is enough for today's session. And if you would like to watch the next part of the video lecture, I would request you to press the bell icon over here to get the latest notification. Thank you very much for watching.